So good day, CSS students. So before we proceed for this lesson, make sure lamang po na natapos na natin yung activity and quiz for the last lesson or the last week. Para po bago kayo mag-proceed dito sa lesson na ito, para hindi po tayo matatambakan ng mga gawain. Okay po? And make sure lamang po na meron tayong gagamitin for take down notes para sa Gmeet natin ay may tackle natin kung ano yung mga question, concern na kailangan natin masagot. Okay po? So we are now for the week 2 and lesson 2. So if you remember for the last discussion, video discussion rather, nagpahapyaw tayo for the logic circuit design about law of Boolean algebra, truth table, AND gate. So meron, nakilala na natin yung mga AND gate natin. So meron tayong AND gate, OR gate, inverter or the NOT gate. We have the NAND gate or NOT AND gate. We have the NOR gate or NOT OR gate, exclusive OR gate, and exclusive NOR gate. So, ayan po. Ngayon, patuloy natin pag-aaralan si Boolean algebra or truth table and si different kinds of gates. Okay po. So, laws of Boolean algebra, sabi dito, a set of rules or tinatawag nga nating laws of Boolean algebra, expression had been invented. Para saan siya? To help reduce the number of logic gates needed to perform a particular logic operation, resulting in a list of functions or theorems known commonly as the laws of Boolean algebra. So what is Boolean algebra? So it uses a set of laws and rules to define the operation of a digital logic circuit. It is the mathematics we use to analyze digital gates and circuits, so we can use this law of Boolean to both reduce and simplify a complex Boolean expression in attempt to reduce the number of logic gates required. It's therefore a system of mathematics based on logic that has its own set of rules or laws, which are used to define and reduce Boolean expression. The variables used in Boolean algebra only have one of two possible values. We have a logic 0 and a logic 1. But an expression can have an infinite number of variables all labeled individually to represent inputs to the expressions. So for example, we have the variables A, B, C, and so forth. So variables kasi pwede natin siyang gamitin letter A to letter Z. No problem for that. Kasi variables lamang po siya. Hindi lang natin or possible lang naman po kapag ay yung pinaka-value na ang hinahanap sa atin. So giving us a logical expression of A plus B is equivalent to C, but each variable can only be a 0 or a 1 value lamang po. Katulad ng sinabi ko, 0 and 1 lang po ang possible na maging value natin or our outcome. Okay? So for the truth table, if you remember for the last discussion, the table used to, truth table is a table used to represent the Boolean expression of a logic gate function commonly. A logic gate truth table shows each possible input combination to the gate or circuit with the resultant output depending upon the combination of these inputs. So we have here the 4 possible combination of A and B for a 2-input logic gate given. So input combination 1, so meron tayong, if you remember, if you hear na for the previous discussion, si 0 represent for off, and 1 is represent for on. Okay po. Si 0 daw ay nagre-represent for off, and Z1 is represent for on. Okay? So, for the combination 1, kapag parehas na yung input natin ay off, ang equivalent niya is 0 and 0. Kapag off and on, 0 and 1. Pag on-off is 1 and 0. And kapag parehas na naka-on is 1 is 1. Okay po. Yun po yung mga combination po natin. Magkakaroon lang yan ng pagbabago once na ano yung hinahanap or ano yung ginamit na gates para dun sa combination ng logic gates. So, for the 2 input and gate, so gawin na lang natin siya class ng si Q, gawin na rin natin siyang as X, okay? Para hindi tayo malito dito sa Boolean expression natin. So, for a 2 input and gate, the output Q is true if both input A and input B are both true. So, pag parehas daw silang true, ibig sabihin, kapag parehas sila ng input na true, ibig sabihin, parehas silang true. So, the given Boolean expression natin for the AND gate is Q is equivalent to A and B, or X is equal to AB. So, tandaan natin, pwede natin siyang basahin as A dot B, or A and B, or simply AB. Okay? So, here's the truth table of AND gate. So, mapapansin natin, and po, we have the A and B input, and we have the Q, or gawin na lang natin itong X para hindi tayo malito. Pero same lang naman siya kasi variables na lang po. So, ang Boolean expressions natin is X is equal to A dot B, or A and B, or simply X is equal to AB. So, ito yung Boolean expression natin. So, ang truth table po ni AND gate ay ganito po. So, sabi ko sa inyo from the previous discussion, we have a default value of A and B. So, ito po yung default value niya. 0, 0, 1, 1, and for B is 0, 1, 0, 1. Then, para makuha natin yung output natin, i-combination natin siya. Kapag AND gate ang ginagamit natin, it's equivalent to multiplication. Okay po. Para makuha natin yung pinaka-output natin. Maliwanag. So, proceed na po tayo kay OR gate naman. So, si OR gate still have a 2-input OR gate. The output Q is true if either input A or input B is true. So, sabi dito, isa man sa kanila ay true, ibig sabihin, ang equivalent nila is still true. Okay? So, ang Boolean expression natin is Q is equal to A or B, or X is equal to A or B. So, ito yung truth table po natin. So, ayan. So, kapag sinabi natin na OR gate is positive or plus. Class, baka maguluhan kayo dito. 0 plus 0 is equivalent to 0. 0 plus 1 equals to 1. 1 plus 0 equals to 1. 1 plus 1 is equivalent to 1. Bakit, ma'am, 1 pa din yung sagot? Class, for the logic circuit design, we only have 2 values. If you remember, we have only 0 and value of 1. Okay po? Kasi, ano siya, kumbaga, kung ano yung input natin, yun din yung magiging output natin, or yun yung outcome natin. So, always remember, Boolean expression for OR gate is equal to X is equal to A plus B. Okay? So, proceed tayo kay NOT gate. So, NOT gate, for a single input NOT gate, the output Q is only true when the input is not true. The output is the inverse or complement of the input giving the Boolean expression. So, sabi dito, kung ang input ninyo ay hindi or NOT gate, di ba ang NOT gate kasi natin inverter or kabaligtaran. So, mangyayari, magiging inverter po yung natin. Equivalent natin for the AND gate. So, here's the Boolean expression po. X is equal to inverter A. Or X is equal to not A. Okay? Next, for the NAND gate and the NOR gate, combination siya ng not gate, yung combination natin ng AND gate and the OR gate and the that gate or the inverter. So we have two input NAND gates. So combination siya ng NOT and the AND gate. So for a two input NAND gate, the output Q is not true if both input A and input B are true, given the Boolean expression of X is equal to NOT A and B or inverter AB. Okay po. So paano naman natin makukuha siya? So, kasi dito, class, sabi ko nga sa inyo, may default value type for A and B. Para makuha natin yung inverter nito, babalik na rin lamang po natin siya. At pagsasamahin natin kung ano yung pinaka-output natin. Okay? So, AND gate, so means multiplication yung gagamitin po natin. Para makuha natin yung output, saka yung Boolean expression. Okay? So next, two input or the NOR gate. So same pa din, here's the truth table. So pagdating dito, always remember kapag OR gate is positive or plus sign. Okay po. Next, as well as the standard logic gates, there are also two special types of logic gates. Function called as an exclusive OR gate and the exclusive NOR gate. So here's the symbol of that exclusive. Meron siyang plus sign inside a circle. So okay po, ganyan po itsura niya. The switching action of both of these type of gates can be created using the above standard logic gates. However, as they are widely used function, they are now available in standard IC form and have been included here as reference. So IC means integrated circuit. So here's the truth table of a exclusive OR gate and here's the Boolean expression. So kung mapapansin natin, inverter A and B, ang input natin, pareho siya dun sa truth table. Papansin natin ha. So paano natin makukuha yung value na yan? So dito, di ba, meron tayong default value na A and B. Tapos, sa A inverter, yung kabaligtaran lang ni A, and for the B inverter, yung kabaligtaran lang ni B. Then, combination naman siya. So, i-combination natin, sabi dito, not A, inverter AB. So, inverter A and B. So, para makuha natin yung value nito. Okay, pagsasamayan natin siya. So, this ay multiplication. So, pagsasamayan natin siya through multiplication. Para makuha natin yung value natin. Okay, maliwanag. Next, sabi dito A and not B. So, si A daw, saka si not B, para makuha natin yung value nito. Okay, then next, sabi dito, pag nakuha natin yung value niya, gagamitin natin si OR gate para makuha yung output. So, kapag OR gate, ibig sabihin is plus sign or addition. So, kung napapansin natin, 0 plus 0 equals to 0, 1 plus 0 equals to 1, 0 plus 1 equals to 1, 0 plus 0 equals to 0. Okay? Nagigets po? Next, we have the exclusive NOR gate. So, for the exclusive NOR gate, parehas na not A and not B. Kumbaga, naka-inverter sila parehas. So, paano po natin siya makukuha? Same process lang din po. We have the default value of A and B, dahil inverter ni A and B din. Then, combination naman siya siya ni, kung papansin nyo, inverter AB. So, inverter AB. So, paano yan? So, ipagkasamahin natin yung dalawang inverter para makuha natin yung value nito. Then, ito naman, so hindi siya naka-inverter, so ang kukuhain natin sa kanya, si A, B. Combination nila para makuha naman natin to. And then, para makuha natin yung value ng output natin, so, OR gate siya. So, itong dalawa. Para makuha natin yung pinaka-output natin. Okay? Nagigets po? So, the following table gives a list of the common logic function and their equivalent Boolean notation. So, ito po yung Boolean notation or yung bawat logic gates yung notation nila. Pag sinabi kasi natin class na Boolean expression, buo ito. Okay? Buo. Kapag Boolean notation, ito lang yung equivalent nila. Okay po, kung ano yung pinagkaiba nila. Next. Boolean algebra example. So, magbibigay ako sa inyo ng mga ilang Boolean expression, then kung paano natin siya makukuha. So, Boolean algebra and the law of Boolean algebra can be used to identify unnecessary logic gates within a digital logic design, reducing the number of gates required, saving on power consumption and cost. We have seen throughout this section that the digital logic function can be defined and displayed as either a Boolean algebra expression or as a logic gate truth table. So, here's the example number 1. So, kung mapapansin natin, ang binigay na, dito kasi class, ano yan eh, magbibigay ako sa inyo ng mga Boolean expression, then gagawin niyo siyang truth table. Okay? Ganun po siya. So, ang first example natin ng Boolean expression is A plus AB. So, si A, saka si AB, para makuha natin si output. Okay? Nakikita yung arrow kung paano. Para makuha natin tong AB, so combination ni A, ni B, ayan. Then, ang hinahanap for the output is si A, saka itong combination ng AB para makuha yung output natin. And our output is here. Okay? Ganun lamang po siya. Kadali kumain. Okay, next. Next example. Paano kapag inverter na? So, kapag inverter, same process pa din po. So, ang inverter natin is A or B. X is equal to A inverter or B. So, si A daw, kailangan daw naka-inverter. So, transfer natin siya into inverter. After that, combination ng inverter A or B. So, silang dalawa para makuha natin yung output natin. Okay po? Yan. Ganun lamang po siya kadali. So, for the last example, so ayan. Paano kung ganyan pareha sila na inverter? So, same pa rin po. So, kukuhain muna natin palagi yung mga inverter nila kung naka-inverter sila. Then, yung kung sino yung mga may combination. So, A inverter, B inverter. Next. Sabi dito, para makuha daw natin to, kailangan natin to si A inverter at si B inverter para makuha natin yung value. Kapag nakuha na natin yung value niya, pagsasamahin naman natin si B inverter at si inverter AB para makuha si output. Ganun lamang po siya. Kadali para makuha natin yung output sa truth Okay po ba? Maliwanag? Okay. And summary for our topic is Boolean algebra is used to analyze and simplify the digital logic circuit. It uses only the binary numbers 0 and 1. It also called as a binary algebra or logical algebra. Boolean algebra was invented by George Boyle in 1854. Truth tables help to understand the behavior of logic gates. So, si truth table kasi klase, ito yung magbibigay sa atin ng proven kung yung ginawa natin na yung Boolean expression natin is tama doon sa magiging output natin. Kasi klase truth table, ito yung checking natin. Sa second quarter pa naman to. Ito yung magiging checking natin for breadboard. Ayun po. So, they show how the inputs of a logic gate relate to its input. The gate inputs are showing the left columns of the table with all different possible input combination. This is normally done by making the inputs count in a binary. The gate outputs are showing the right-hand side column. So, ayan po yung pinaka-summary na lesson na ito. And class, I required you siguro na umattend for our G-Meet para address ko agad yung mga questions ninyo and siguro makapagbigay ako ng sample ng live sa inyo, virtually sa inyo. So, ayun. See you in our G-Meet schedule and I hope na bago tayo umattend sa schedule is napanood na natin